to discuss one of the problem which came recently in 2020 IB physics paper. It was a paper from October and November. So let's discuss this problem. Okay. So over here, you can see that in this question that there is a person standing in a amusement park, right? It's like basically a ride, okay, in an amusement park, and the person is standing against the wall. Okay. So it's something like this. Suppose, let's say if I take an example, let's say this is the wall against the person standing, and let's say this is the person. Okay. So person is standing like this, horizontally straight. Okay. And this person is moving in a horizontal circle like this. Okay. It's just going in a horizontally in this circle. So this is kind of a ride. Some of you might have ridden, or some of you might have seen it, right? So what is happening? This is basically the person is standing against the centripetal force, which is helping the person to stand still, right? There is no belt on the person over here in the situation. Obviously, in real situation, when you go to such rides, they always put a belt, okay, across you, so that obviously you don't slip. But in this case, assuming that there is no belt, we have to find out particular conditions such that the person do not slip from or go down basically below it. Okay. So first question over here, it says that draw and label the free body diagram. Okay. So basically, if I draw the free body diagram of this person, let's take it point object over here. All right. Now on this object, you can see that there is a friction force and there will be mg acting. Now, why there is a friction force? Obviously, the person is standing against some surface, right? What does friction do? Friction basically tries to stop a body to go or basically to oppose its motion, basically, right? Now, if suppose, let's say the friction is not there, suppose what will happen to the person? The person will fall down, right? What is the role of the friction? The friction is basically here to stop the person from falling. All right. So that is how you decide the direction of friction force, correct? Now, over here, so mg is done, F is done. So one more force, which is the normal reaction force, has to be there, correct? Now, why a normal reaction force? Because the person is standing against a surface. Normal reaction force always acts perpendicular to the contact surface, if you remember. All right. So this is the free body diagram of the person. Okay. Most of the students, not most, some of the students, I will say that they do what they do. Basically, they put the centripetal force also in this case, but that's not the thing which you need to put. Centripetal force is the net force, which is generated due to some force. So this is the final diagram we have to show. All right. Now let's look at the B part of this question. So what this says that the person must not slide down the wall. Show that the minimum angular velocity omega of the cylinder for the situation is this. Okay. So this is the thing we need to show over here. Now it is given that the person should not slide down. If the person should not slide down, so definitely my friction force has to be greater or at least equal to mg. Right? Then only the condition will come that the person will not slip. So the friction should be sufficient enough so that mg should be less than that. That's the case, right? So now what is F? F you must have studied earlier. It is basically mu into N, right? That's the basic definition of the friction force, greater than mg, right? Okay. Now what is N? N is what? N is doing, providing the centripetal force. So instead of N, I can write N as m omega square r, which is the centripetal force. I will substitute its value over here. So I'll get mu m omega square r greater than equal to mg. Correct? M and m will cancel out. I'm getting a condition of omega greater than omega square greater than equal to g, and there's mu and there is r. That implies omega has to be greater than equal to root of g mu r. Correct? That means the minimum value of omega minimum, will come out to be what? Under root of g by mu r, isn't it? So that's how we basically get this answer. Correct? All right. This is the B part of the question. Now let's look at the C part of that. The C part says that the coefficient of static friction between the person and the cylinder is 0.4. So I have given the mu value over here. The radius is, they have given 3.5. The cylinder makes 28 revolutions per minute. That is the time period or frequency they have given to us. Deduce whether the person will slide down. Now see what we have to find out. So whatever the mu minimum, first we will figure out what is the mu minimum in this case. And with the revolutions given, we will find what omega they are basically, the person is rotating. So with that, if that mu, which we find out is greater than this omega minimum, then the person will not fall. All right. Okay. So let's see this question. Okay. Let me just rub this off and let's see the C part of this question. So in the C part, what we have basically mu. So what we'll find out omega minimum, let's find out what the value is. Omega minimum is basically G, which is 9.81, and mu, which is what they've taken 0.4, and R is what 3.5. All right. Now, when you calculate this value, it will be at approximately 2.6 radians per second. Okay, I have calculated earlier. Okay, you can check it. It will be around 2.6 radians per second. Right. Now, what is the omega from which the information is given to us? So they are given the time period. The time period is basically what, 60 over 28, isn't it? Because it is 28 revolutions per minute. That is, in 28 revolutions, that's doing in 60 seconds. So basically, one revolution will take in 60 over 28. Right. That is basically the time period of that. So what is the omega? It is 2 pi by t. That's the formula, right? So 2 pi over t is what? 60 over 28. Now this value, when you calculate, will be approximately 2.8 radians per second. So that means to say that the omega which is the that park ride is basically moving, it is greater than the omega minimum value. So the person will not slide down. All right. So it's a safe condition for the person to stay. Okay. All right. So that's it for this demo. Okay. Hope you liked it. Thank you.